Okay, so example 2 is find a missing length or a missing leg of a right triangle. So they specifically said a missing leg, and actually they were given B, right? B is equal to 150 centimeters. Okay, so we want to find the missing leg. Okay, well, the missing leg is A, right? C is not a leg, it's the hypotenuse. If they ask you to find it, then you can find it, but they specifically say find a missing leg. This is a 40 right here. So I'm given a triangle with one leg, and I can't use the Pythagorean theorem because I need two unknowns, right? If they gave me the hypotenuse, then I can find A, but they didn't. So this is where we use the trigonometric ratio. And you can use the sine of 40, the cosine, or the tangent of 40. But you have to ask yourself what you want. Well, you want this A. So you look at your acute angle, which is 40, and you ask yourself, well, what do I know about a ratio with 40 degrees and maybe the opposite of that angle? So the book uses, and well, the reason why they use, whoops, I didn't want blue, but okay, we'll say blue. So the tangent of 40 degrees. Okay, 40 degrees because that's my A, my tangent of A. And what is the tangent of A? The tangent is the opposite over adjacent angle. So opposite of 40 degrees, opposite is A. Okay, and we want A in there because that's what we want to find. Over adjacent, well, the adjacent angle is this B part, which is 150. Now, the reason I didn't use sine of, let's just say sine of 40. Well, the sine of 40 is opposite, okay, that's A, over, that's hypotenuse, and my hypotenuse is C. Well, I mean, this is not wrong, but this is not going to help us because we don't know, right? We don't know what C is, so we have two unknowns. And then similarly, if you use cosine of 40 degrees, well, the cosine of 40 degrees, by definition, is the adjacent, side adjacent, right, to angle 40 over hypotenuse. So that would be 150 over C. And then you would find C, which, I mean, technically you could use this one, but then you have to use the Pythagorean theorem after to find side A. So, I mean, this one's not wrong. It's just a little bit longer. But this one's pretty straightforward. So we're going to use the tangent of 40 degrees is A over 150. And then we can solve this equation. And there's a nice little review on page 661, right, which is multiplying by the least common multiple, or technically you're really just cross multiplying because you have two ratios. So let me go back to white. Okay, so here's our proportion, right? We can cross multiply. A times 1 is A, and tangent of 40 degrees, right, times 50, or 150. So in your calculator, right, you can punch in tangent of 40 degrees. Make sure your calculator, make sure the mode, right, is in degree mode. Right, there's a radian mode and degree mode. Make sure it's on degree mode. And it depends. If you have a scientific calculator, you might have to punch in 40, then tangent. Or other calculators, usually graphing calculators, you put in tangent of 40 degrees. So I would put in the tangent of 40 degrees, and then it'll give you a value. And then just multiply it by 150. And they want you to, let's see, round off, or let's see, what are they rounding off to? Okay, so I'm actually using my iPhone as a calculator. If you rotate it horizontally, you'll get the scientific calculator. So mine is 40 and then I'm going to hit tan, which is tangent. And on my calculator it says 0.839099 and so forth. But I'm just going to go ahead and hit times 150 because that's what I want. And I get, so approximately 125.8649 dot dot dot. And obviously, right, they just want the whole numbers. So that would be 126 centimeters for A.